My name is John Favaro. I'd like to welcome you all to the third and final day of our first SWForum.eu workshop on trustworthy software and open source. I'm reading it on my background. So I'd like to start out like we did in the other days as the people arrive, saying a few introductory words about SWForum.eu. It's an initiative funded by the European Commission and runs until March 2023. So we have a full 2 years of activity ahead of us. The first goal is to create a European forum that is sustainable beyond the end of the project, where researchers can share knowledge, initiatives, insights, opinions, especially in our 3 areas of particular focus. That's software technologies, digital infrastructures, and cybersecurity. We certainly want to involve those of you who are currently running H2020 projects, of course, but we also welcome interested people from other initiatives and even individuals who would like to participate in a personal capacity. The second goal is to contribute to the research and innovation roadmaps of the European Union, especially in those 3 topics mentioned before: software technologies, digital infrastructures, and cybersecurity, so that the European Commission can use them as input for the upcoming work programs. This was requested of us by the Commission. So this is a real opportunity for all of us to have a real impact. And something very exciting is also an explicit request from the Commission, which all of you heard who were here on the first day, to add open source as a special area of focus, which you can see reflected in the program of this workshop. I'd also like to mention another very interesting third goal, which wasn't introduced in this workshop, but we'll address it in future workshops. It is the assessment of existing H2020 projects in their technology and market readiness level as support for them in their go-to-market activities. So stay tuned for this topic in future workshops. And with that, let's move to today's program, which is full of presentations that touch on all aspects of our main focus areas, many of which have been brought up in our various keynote speeches throughout the workshop. So without further ado, the first presentation is about the MEDINA project, which will touch on cybersecurity, cloud, and trustworthiness, for example. Over to you. I believe it is Leire, correct?
Yes, yes. So you can see my screen, right?
Yes.
Okay, perfect. So I will be speaking about a project that is called MEDINA, and it's actually focused on continuous cloud security certification. So the motivation of this project is as follows. Even though cloud technologies, let's say, is a mature technology, the adoption of cloud is rather low. So according to Eurostat, around 26% of the companies use cloud services, and they are mainly related to email services. So Eurostat launched a survey, but also ENISA did the same, and also Technalia did the same in a study for the Commission, to try to understand what was the main rationale behind this low adoption. And these were the top 5 aspects. So risk of a security breach, where the data was stored, what would happen if I had a problem, so where should I complain, what is the legal jurisdiction of such a provider, also insufficient skills in developing applications for the cloud, and also lack of interoperability, especially when switching cloud service providers. So the Commission asked himself or herself several years ago, could certification be a solution? And based on a study done for the Commission, we saw that there are many certification schemes out there. So in the left, you will see the, let's say, international certification schemes that are out there, ISO 27000, CSA Star, and also the adoption rate, let's say, by the top 50 CSPs in Europe. in the right, you will see the certification schemes coming from the European member states. So what is the problem here? That there is a duplication of effort. If you actually see the number of certification schemes adopted, you will see the most adopted one is ISO 27001, which is not really a cloud security certification scheme. It's an information system management, information service management system. Another thing from that study is they compared control by control these certification schemes, so and standards. So ISO 27002, 27017, CFAC coming from Germany, NIST 853 coming from the US. We reviewed here revision 4, now it's version 5. Also the Cloud Security Alliance Cloud Control Matrix, and we compare that with the baseline, which is the study done by ENISA many years ago in 2014, in which they defined a meta framework of cloud computing schemes. And what we saw here is that if you see, you will realize that each certification scheme covered different or have focused on different aspects. For instance, C5 focuses a lot on operational security, while ISO 27000 focuses a lot on procurement management. So what does that mean? That when a CSP, when a cloud service provider wants to get certified in various schemes, they have to design more measures and they have to implement differently controls, or they have to focus on different aspects. Also, in the certification world, there are two assessment methods. One is ISO-based and the other one is ISAE-based. ISAE is used specifically by the accountants, and ISO is usually based on 17065 methodology, which is a conformity assessment methodology quite known in this domain. So to overcome this issue, the European Commission has been working on several regulations to promote the use of cloud computing and also to avoid this fragmentation in the certification world. So this started in 2012 with the European Cloud Strategy, in which they said, cut the jungle of standards. I will not go into the details of all the different steps. I will stop in two steps. One is June 2019, in which the Cybersecurity Act was established. And the Cybersecurity Act establishes a certification framework for Europe for ICT process, products and services. And then in December 2020, we have the first draft scheme of the European Cloud Services Certification Scheme. For the time being, only two certification schemes have been worked on. The first one is Common Criteria, so GAIS, and the second one is the Cloud Security Certification Schemes. The third one is 5G, and actually ENISA has recently received the mandate from the Commission to start working on it. So MEDINA is actually focusing on the Cybersecurity Act and specifically on the EUCS, on the Cloud Security Certification Scheme. And what we are trying to do is we are trying to provide a framework that focuses on cloud security aspects of cloud services, of course. What we want to do is enhance this, the trust of the customers by providing them with certified services. And we are focusing mainly on the high level of assurance. I will explain this later on. What we want to do is we want to create the tools that would allow cloud service providers to continuously audit their different controls. So the Cybersecurity Act defines 3 levels of assurance: basic, substantial, and high. They also include the notion of continuous auditing, and they recommend to follow a risk-based approach. Out of the certification schemes that I've shown before, only NIST has this notion of 3 levels. The other ones only have 1. And they also consider discontinuous auditing, but neither ISO 27000 or the others consider this notion. So the European Service Certification Scheme also defines these 3 levels of assurance based on what the Cybersecurity Act says. The level high is we have a set of controls and we have a set of requirements, and each requirement is placed on a security level, so an assurance level. So you have assurance level basic, substantial, and high, and the requirements are cumulative. So in order to get certified in the high level of assurance, you have to be certified in basic and substantial. If you want to get certified in substantial, you need to be certified, you need to comply also with the requirements on basic and substantial. But that's not only it. We have also the notion of depth and rigor. That's how stringent the conformity assessment is going to be. And here, for instance, they consider operational effectiveness. That is, if you want to get certified in the substantial level, you need to demonstrate that your controls are effective for a certain period of time, usually 6 months or 1 year. In the case of the high level assurance, what they demand is this automated monitoring. They do not go as far as the continuous auditing or continuous certification, but they demand to be monitoring in an automated way all the controls identified as high. Looking into state of the art, there are not many tools that allow this. So this is quite an immature field. So MEDINA is focusing primarily on the automation of the security requirements identified as level high. So what we want to do is create these monitoring tools. Although, since substantial level needs to demonstrate also the operational effectiveness, this requires also some kind of automation, because you need to be able to gather samples during a certain period of time in order to be audited. So some of these requirements will also need an automation, and that's also the scope of MEDINA. So the approach of MEDINA is as follows. So you see the gray boxes define like the major steps. So first you have to identify the controls and the metrics that you need to apply for your target assurance level. The metrics are, so there are certain metrics that can be identified as common, but you have to define the target values, and that's proprietary of a CSP, depending on the risk appetite that they want to bear with. Then you have to collect the evidences, evaluate the evidences, and then we have incorporated here also the continuous auditing notion. So the main results that MEDINA will develop is this catalog of controls, requirements, reference, technical and organizational measures and metrics, so that the CSPs, especially the small ones and medium ones, can have some guidance in how to implement the different requirements required actually by the EUCS. Based on this and this iterative process, the CSP will perform a static risk assessment to see how or what they want to do with their requirements, if they want to transfer risks, if they want to accept them, if they want to mitigate them by putting some organizational measures in place, and so on and so forth. You have seen there that I've put technical and organizational measures. So metrics are usually for technical measures, but we are also focusing here on organizational measures. Organizational measures are documents, for instance, policies, procedures, and so on. And there's only one way to analyze this, and this is with natural language processing. So what we are trying to do is we are trying to translate the Cybersecurity Act and the EUCS into a machine-readable language that we call the certification language, so that we can then assess whether a document complies with what is required by the scheme. Then we have tools that collect continuously different evidences. And evidence is, for instance, a document, is for instance a set of database, is for instance some tables of a database and a sample of some rows. It can also be a password or a list of passwords. So there are many different types of evidences, and evidence can be a document, a sample of a database, a source code, a script, many things. And one important thing is that if we collect these evidences in an automatic way with a tool, we need to verify that the tools do not tamper with the evidences, so that they are as they are, so they are trustworthy. So here we're also ensuring their trustworthiness with DLT approaches, blockchain and so on. The final step is the actual evaluation. So here we have the continuous evaluation of these evidences with respect to the target values defined. And also when a non-conformity is identified or a non-compliance is identified, then we will have this dynamic risk assessment in which new metrics or new target values will be identified and a new risk assessment will be developed. So which are the benefits of MEDINA? So the first one is to ensure that the cloud services that are offered to the customers are trustworthy and that the customers trust them. Also for the CSPs, we want to reduce the effort and the time and cost of obtaining the certification, because we help them in the selection of the implementation measures, recommendations of metrics, and also we provide these tools for the automatic compliance and also for the collection and evaluation of evidences. And then we also ensure that no one has tampered with the evidences, so that the evidences are as they were in the moment they were collected. And finally, which are the main users of MEDINA? So we have the CSPs, the cloud service providers. The UCS focuses on cloud services, not cloud services providers. And the scheme does not distinguish between IaaS, SaaS, PaaS, or whatever as a service, whatever thing as a service. So we just consider cloud service capability. We just don't say this is for IaaS, this is for SaaS. Another target user is the auditors, depending on how we deploy MEDINA. It can also be used by the auditors themselves as a tool to be used in their auditing procedures. Conformity assessment bodies, because they need also to assess some of the evidences collected, and the national certification authorities, especially for the high. And this is it. So any questions, comments, they're more than welcome.
Any questions? I have a general question that is to you and perhaps some of the other experts in this group who I know are here. I have heard that the security certification organizations are very, how should I say, backwards in this respect, and they're very slow in accepting automation. They want to see stuff, they want to see documents, they want to see paper, and they don't want to have machines in the middle of it. Are you encountering any of this?
Yes, actually we have two CSPs in our project, and we have one CSP that actually has this issue that why should I trust your tools to collect my evidences? And this can be done in various ways. And one way would be to have a certification scheme that actually allows tools to be certified. So there will probably be a certification scheme at European level that will certify the audit services, so the auditors. And this certification scheme should, in my opinion, should also cover the tools. So that if you have a tool that is certified, then you can trust that this tool is trustworthy and that it doesn't modify anything.
Yeah.
Thanks,
So,
Matthias. Looks like you're about to start.
Yes. So we are currently in a common criteria certification project in evaluation assurance level 4, which is pretty high for a general purpose OS. And the Corona crisis, I think I can reveal that much, forced the authority to not have a physical site visit, which is part of such a common criteria certification. So effectively, what we had to do was an online video session, a full day, where basically the evidence was then given to the authority. That was the first time ever that was done. However, I have to admit that I see a value in the physical evidence, because depending on what level of certification you are playing with, not everything can be automated or just be done by hand waving or SLAs. You need to get to the point and really touch things or see things. I would not describe that as backward. I just see different understandings of security and the needs for that. And my thoughts about a secure software supply chain are very much related to the view and the need for potential even physically evaluating and validating security, because there is a level of security that you can just not testify if you have not touched it. And the farther you go away from the evidence by automation or machines, the more SLAs, which are just hand waving in the end, need to be accepted, and then the quality of the certification is not necessarily where it should be, given the specific assurance level you want to get to.
Yeah, so in MEDINA we're trying to automate as much as possible, but that does not preclude that an auditor, for instance, or a conformity assessment body can come into your company and can actually inspect and evidence themselves. So we are trying to help the CSPs, the cloud service providers, in collecting these evidences in an automatic way and be able to react as fast as possible. But there is the human in the loop, let's say, approach that still needs to be done, which is the interviews that the auditors do in order to see that everything is working properly. And also they might require additional evidence because there is something they don't believe in. So that's also some of the parts that we are also covering in MEDINA. Indeed, we have a set of auditors that will also help us with human in the loop stuff.
David.
In terms of the collection of evidence, of technical evidence from the different types of cloud service, how do you verify the measurement for each of those?
I don't know if you mean the measurement of the measurement result, because we have this polemic still at the level. So we have the target value of the metric. For instance, password has to have a 14 characters, having lowercase, whatever. And then we go through, for instance, AWS, and we collect a list of passwords that we have, and we do this policy. We have a policy rule that actually says password has max characters 14, and then has uppercase, has lowercase, whatever. And then, so that's a policy rule, right? And then the final comparison is what we call a security assessment rule that compares the results from these measurements with the target value that you had defined. Okay, and do you do any you talked about continuous testing. So do you do any testing actually of the physical infrastructure of the provider? We do continuous auditing, which is not really the same as continuous testing.
Okay. So the reason I ask actually is that I have a project and a patent in a trusted computing-based attestation of cloud services, which is currently utilised by the UK government up to the level of restricted across 9 different departments. So we're quite interested in other solutions that people have around automated measurement and testing to create cryptographically secure cloud services.
Okay. I can put you in contact with the partner developing this part.
That'd be cool.
Offer.
Yeah. Thank you.
Thanks very much. If there's any other comments. Okay, otherwise, we can move on to the next talk. In fact, the next presentation is, I do not see, at least I don't think I see the authors of the presentation in the participants list here. That would be Romeo, Kienzler, or Ivan Nesic. Is that correct? Do I not? Is there anybody here who will present that paper? If not, we will move on to the next one. Okay, in that case, let's move on to the next presentation. And of course, if they appear, then we will hear from them too. Okay, so the next presentation in that case is about that Piacere project, which will touch on one of the key pillars of SWForum, which it's digital infrastructure. And we'll start the discussion going on DevSecOps, another subject that Tony had touched upon way back in our very first keynote last Tuesday. So I'll turn over the floor now to Juncal.
Yeah, thank you, Jan. Hello. So let's see if you can see my screen. Okay, can you see it?
Yep.
Okay, perfect. So hello everyone, I'm Juncal from Tecnalia, and today I will present the paper titled Programming Trustworthy Infrastructure as Code in a Secure Framework, which indeed is a paper about a research project that started in last year, in December 2020, and which is called Piacere. This is a H2020 research and innovation action that will last through the next 2.5 years. So given the time constraints we have for this workshop, I just wanted you to give, let's say, a high-level overview of the project and of the objectives we have and the approach we want to follow to get into them. And if you want to know more about the project or get more information, you just can ping me or write an email or check the website or whatever. So let's start with the context and motivation, which is behind Piacere. So in the last years, it is true that it has been, let's say, a virtualization revolution that has taken place. And the combination of this virtualization revolution with new, let's say, approaches like the cloud computing continuum, which indeed is a combination of cloud, also different and heterogeneous infrastructural elements, for example, coming from cloud and the edge and the IoT. This has allowed for an increase in the use of the software that it is used to build, operate, manage, and control all these, let's say, infrastructural layer. In this, let's say, the significance of software has grown to the point of merging both, let's say, both worlds or both roles, typical and traditional roles of developers and operators of the infrastructure, whose main focus is indeed the automation of or infrastructure-related activities through the use of software. So that was give birth to the infrastructure as code trend, which in this we can see as, let's say, the heart of the DevSecOps or the DevOps movement, let's say. So this infrastructure as code trend enables the automation of deployment configuration and management tasks that otherwise they would be performed manually by the operators. So this is very nice. This trend is really, let's say, really nice, but unfortunately, we still, or IAC or infrastructure as code trend still suffers from several issues. And here you have a list of 5 of them, which we are focusing on in Piacere. So first of all, the thing is that there are a lot of programming languages for writing this infrastructural code. And indeed, let's say each of the languages, they focus in a single or a small set of steps or activities, or even of type of resources, for example, virtual machines. On the other hand, current approaches, they are focused mostly on the cloud computing infrastructural elements, but they don't, let's say, cover other computational resources, such as resources in the edge, or let's say more lightweight resources. Then they are not really end-to-end solutions. They focus on certain phases of the lifecycle of such IAC or infrastructural code, such as the provisioning of the infrastructure code, the configuration or the deployment, but it's not really this end-to-end solution covering the whole DevOps cycle. And last but not least, trustworthiness and security aspects of this infrastructural code are often left for the end of the cycle. So for once, the code is already in operation and not from the design phase. So, and usually this is too late. When something happens, some errors are there, some vulnerabilities are expensive to correct if we detect too late in the cycle, and they can affect indeed the business continuity of the application. So with this context and this situation, what is Piacere pursuing? So what we want to do is to enable most organizations to embrace this infrastructure as code, let's say, approach. How? Through the DevSecOps philosophy. So we want to support the whole life cycle of the infrastructural code as if there were, let's say, traditional software. And at the end, what we want to obtain is to increase its quality, its security, and trustworthiness, and also ensure its evolvability and its business continuity by providing self-healing mechanisms and self-learning mechanisms that will allow, let's say, the code itself to anticipate to failures and to learn from runtime conditions and to let's say, predict that something is going to happen. So how do we want to achieve this? Well, this is a typical picture that we usually show when talking about Piacere. So what we want to do is to put the infrastructural code in the middle or in the center of this traditional DevOps or DevSecOps infinite loop that was indeed shown in the first keynote days talks. And we want to provide tools, means, techniques to support, let's say, each of the phases here in the loop. First of all, at design time, we want to support, let's say, the modeling of the different infrastructural resources, covering not only these cloud resources, but also network and other kind of infrastructural elements. And we also want the developers to be able to characterize those infrastructural elements based on their description of both functional and non-functional requirements that are required for those infrastructural elements. Apart from that, moving on to the let's say the creation or generation of this infrastructural code, we want to, from this model, to automatically generate this infrastructural code independent from the target environments or the target resources that we have selected, and independent from the different programming model languages. We also want to, let's say, to verify both at model level, at code level, the correctness and the completeness of this code and the models we have created. We also include what we call a pre-deployment phase, or pre-execution phase, where we want to emulate, let's say, the IAC, the generated IAC, previous to putting into production. And in this emulation, we already perform an optimization of the deployment configuration so that the best combination of the infrastructural elements are selected. This is done by means of multi-objective algorithmia and artificial intelligence-based techniques. Once we have, let's say, emulate the code and selected the best deployment configuration schemas, we also want to automatically orchestrate the deployment, that is, execute this infrastructural code and create the required infrastructural elements in the providers or in the supporting the different resources we have selected, and of course deploy the containers or whatever application related components there. And last but not least, we at runtime, once it is everything is running, we also want to monitor and analyze this monitoring information so that we can trigger a redeployment if needed, or some self-healing activities because something is going to happen or it's already happening at infrastructural level. So that's mainly the main approach. And I'm not going, let's say, through all the components that we plan to implement as outcomes of the PHR project due to time constraints, but I have listed here them. And I have grouped them in let's say, or following this life cycle approach. So for the modeling part, we have this DevSecOps modeling language that we plan to implement with the corresponding extensions for new programming language or new infrastructural elements that may arise in the next years. Then we have the infrastructural code generation that automatically generates this IAC. And all this is integrated in an IDE, which this IDE is also connected to the security or the verification tool, and also the security inspectors related components there. This is the canary environment I have been talking about to emulate the IAC prior to the production. The optimized platform, which provides these optimized deployment configuration schemas, and the IAC automatic execution platform, which indeed executes the generated infrastructural code. And at runtime, we have this runtime monitoring stack, let's say, which is feeding the self-learning and self-healing mechanisms, and based on this information here, some actions can be triggered. For example, if new infrastructural elements need to be generated. So, what are the benefits of PHR? So, we want to make the creation of this infrastructural code more accessible, more easy, let's say, to the DevSecOps team. We also want to increase the quality, security, trustworthiness of this infrastructural code, and treating it as, let's say, normal or traditional code. And at runtime, we also want to ensure the business continuity by providing these self-healing and self-learning mechanisms, so that the IAC it's able to learn from previous conditions that trigger some unexpected situations. With respect to the innovation we propose with this approach, going to the innovation related to IAC solutions, we want to support different infrastructural code tools and different programming language in a single IDE. We also want to be able to integrate heterogeneous resources and infrastructural elements, different types of resources and infrastructural elements. And we also want, or another aspect is for us that this relevant is that this approach is extendable, because these, let's say, languages and infrastructural elements are rising almost every, I don't know, 6 months or even less. At the infrastructure modeling and abstraction level, we want to create this model which is independent from the target IAC tool. We also want to provide this extensibility, let's say, mechanisms for the languages supported, and we want to provide kind of this modeling environment, to be able to easily create these models. With respect to verification and simulation, we will provide this canary environment, which indeed serves for the emulation previous to the actual execution of the infrastructural code. And then we also want to focus on the verification of the code and testing of this code, as well as on the critical or safety or security related aspects. Indeed, for us, let's say the security part, it's really a concern, and that we think it's not tackled enough when developing, designing, and operating this kind of code. So we are going to propose both a static and dynamic analysis of the code with respect to security, so that we can detect the vulnerabilities before the applications are deployed into production, which currently is not the case. And then at runtime, once again, we want to apply this multi-objective and heuristics to this domain, to the IAC domain. So this can help optimizing the deployment configuration, and it can help also detecting this or predicting, let's say, these dangerous situations. So that would be it from my side. I hope I stick to the time. I'm not sure, but well.
Thanks very much, Juncal. So are there any questions off the bat? Any immediate reactions? If not, I certainly have an immediate reaction. You brought up...
I have
yeah.
one comment,
Yes, okay.
question.
Go ahead.
Well, I see that there are several similarities between the Jesús project and the project I'm going to introduce in the next talk. Mm-hmm. I'm particularly interested in those modeling aspects. I mean, you are commenting about the main specific language you are planning to design and implement in order to support the specification of some aspects of the, I guess, DevOps lifecycle, mm-hmm. implemented within an IDE. Can you provide me more information? I mean, are you planning to reuse existing standards, or you're planning to create those domain-specific languages from scratch?
Yeah, indeed. One of the main, let's say, or initial activities of the project with respect to this concrete part has been to analyze existing modeling language like Camel, Tosca, etc. And we are now in the, let's say, in the way of selecting if we are going to extend any of these or which approach to follow.
Okay, thank you.
I was going to ask about two things that seem to be not in contradiction, but opposed to each other. Both of them were brought up by Tony in the first keynote on Tuesday. One was, well, the DevSecOps process certainly brings in more transparency into the process, and so that's certainly a good thing, that's for sure. And it ensures including more security mechanisms, etc. But you also mentioned the self-learning, the self-healing, and that sort of thing. Now, and that was also mentioned by Tony as being in danger of bringing in more, less transparency, less clear exactly now what the system is doing. Have you? Is there going to be a problem? Let's say you talk about verifying the system, etc. But if the system is consistently changing itself, learning for new things, won't you have the problem with consistently verifying that everything is still okay?
Yeah, I think it's a little bit early to talk about that because of the stage of the project. But of course, that's for sure. I think that's one of the problems of the artificial intelligence in general. So that people want to know what the algorithms are doing, let's say, behind the scenes, no? And yes, we need to consider that part. To be honest, at these stages of the project, we are more focusing on seeing which kind of algorithms can we use, which kind of data can provide, let's say, relevant information for these algorithms. But of course, we also need to tackle that into account. And I remember that at proposal level, we identified this as a risk, let's say, that we need to tackle for the AI or artificial intelligence related part.
Okay, Matthias, I think you.
Yeah. So my question back to you would be: on what level do you see the change happening and the abstraction? If you think about the single system, I think if we are talking infrastructure as code, then a single system should never deviate from the infrastructure proposal that is given by the infrastructure code environment. However, you are certainly right if we are talking about the changes happening automatically on the infrastructure at code level, and then human control or let's say certification of a specific environment might conflict the approach of auto-optimizing it. So it really depends. And here, I think the only thing that my proposal is that you really need to describe the real process, how a specific change goes into the infrastructure code environment, how the change is documented. And second is that the artificial intelligence infrastructure, so the systems behind, are specifically protected against tampering with, which could mean that if you have a cloud environment is deployed with infrastructure code, as absurd that might sound, the engine that you're using to calculate the changes are not in the cloud, but are specifically protected, potentially even with physical access controls and such, so that you can really be sure that nobody tampered with your way of interacting. So that might be the levels of, I think in security, we are talking about a trust anchor. So you need to define the trust anchor even in such an environment. And in such an environment, the primary trust anchor would be with your AI engine. That would be my answer.
Okay.
Yes, I've seen similar things happen in safety-related systems too. Dave, were you about to say something?
Okay.
No, not me.
Oh, okay. In safety-related systems, I have seen also the idea of, well, you can call it a safety anchor, I guess, but within the overall environment that includes AI, like vision system or something, they try to wrap around it a known safety context where you cannot get out of that envelope with the AI and do into something that cannot be verified as such. So it sounds like a similar concept is being used in other mission critical applications.
I just quickly on what Matteo said, I suppose I would suggest that maybe the root of trust actually needs to be somewhat separate and somewhat measurable to ensure that it is maintained through operation. You know, from my point of view, roots of trust to me have to be things that can be, that are separate from the things that they're actually being utilized to sign off on in terms of operation, and they need permanently, it's really nice if they are, physical systems, which is why I, with my trusted computing hat on, I always go down that route.
Yeah.
So you are talking about trust on the, let's say, on the artificial intelligence part,
yeah,
right?
Yeah. So the artificial, so one of the biggest problems, is how do I trust the artificial intelligence is actually doing what you say it is, and how the only way you can do that is by measuring it before it starts, running it, keep measuring it, and let me see that measurement so that I am able to verify that measurement is what you say it was right at the beginning, and that it is that value all the way through. And therefore, and if that value changes, I can then choose to disengage with that. And that allows me to make a react and respond to something that your AI, to the change of state of your AI.
Yeah, indeed. These first activities with respect to the artificial intelligence part and the algorithms we are developing there, we are starting also by monitoring, let's say, real infrastructural elements there, and try to start learning about the tendencies and how the things go there. So that afterwards we can, let's say, base our decision on those learn concepts or tendencies. Yeah.
Okay, very good. Thanks very much. Great discussion. While we're on the subject of AI, let me remind you that although unfortunately the authors of one of the presentations were not able to come today, their paper is about exactly that, about AI and also the trustworthiness of AI. So please, in any case, take a look at the paper, which is online along with the rest of the program. Okay, so our final presentation will introduce the Sodalite IDE, at least I think that's probably how it's pronounced, and which will continue the discussion of the issues associated with digital infrastructures, which I'll remind you is one of our most important focus areas. So over to you, the floor is yours, Jesús.
Okay, good afternoon. You see my slides, right?
Yes.
Okay, so good afternoon. My name is Jesús Gorroñogoitia. I'm representing Atos and also the Sodalite project. In this talk, I'm going to talk about the smart development environment, the IDE. We have developed it for Sodalite in order to support the deployment of complex applications in heterogeneous infrastructure using infrastructure as a code. So the main motivation of Sodalite is that we need to tackle with the deployment of complex applications that may consist of multiple components that are structured according to different technology like services, microservices, batch jobs that could be executed in high performance computing clusters. And all of them are requiring different non-functional properties to satisfy them or even to provide them. This application needs to be deployed across different infrastructures, including HPC, including edge, or even cloud infrastructures. And the main purpose of the project is to provide dependable and trustworthy deployment of these complex application in heterogeneous infrastructures. So the approach is implementing is based on 3 phases. In the first phase, which is the modeling phase, we need to provide models for all those aspects of the deployment that are relevant, including the modeling of the infrastructure resources where we can deploy our application components, the topology, the deployment topology of the application itself, and also the aspects related to the optimization of some concrete components, and also the description of the implementation of operations for those components life cycle. Once that those models has been created, we need to use IRC solution in order to create the deployment artifacts that are required in order to apply the actual deployment, like building the images for containers or virtual machines that are required for creating those infrastructure resources, or creating the final Tosca blueprint that is required in order to conduct deployment of the topology, as well as to be able to complement the infrastructure resources that can be modeled in the modeling phase by discovering new infrastructures in an automatic way, and also to validate by using IRC techniques all the deployment artifacts that are built, as well to detect possible smells by comparing with a library of smells and building those component operational implementations. In the last stage, runtime, we are actually deploying the application using an orchestrator that supports parallel deployment and to be able to resume failures, failing deployments from the point of failure, another additional orchestration feature that we are implementing, as well as to provide dynamic monitoring, which depends on the kind of application and resources that are being deployed, and to be able to introduce refactors in this deployment upon the detection of violation in the quality of service that is expressed as policies in the deployment topologies. So there are different aspects here in which we are trying to improve the trustworthiness and dependability of the this complex deployment in all these different phases. In the remaining of the presentation, I will focus on the modeling part, which is supported by the IDE, but we can also answer other questions related with the other phases, because some colleagues of mine are here attending and they have expertise on these phases. As the modeling of complex application is a very complex activity that requires different expertise, and also we are addressing different modeling cross-cutting concerns. We need to split this concern and to address specialized roles by providing specialized PSLs. So first, we have the resource expert, which is able to define infrastructure resources by creating resource models using a specific domain-specific language created for that purpose. Similarly, we have application app experts, which can provide the description of the application topology in application deployment models. Also, quality experts, they can provide optimization models for performance tuning some of the application components. And the same application of experts can provide as well models describing the implementation of the operations supported by the component lifecycle. The main model, which is the ADM, describing the deployment topology, could reference other entities describing other models, for instance, resources, or also optimizations applied to application components, as well as Ansible playbooks supporting the life cycle of those components. Similarly, in case of the resources that are requiring as well these Ansible playbooks descriptions. So here we have the entire split of modeling concerns and modeling roles, which are supported by the IDE. So the IDE is a combination of two main components. One is the IDE, which is providing the first supporting the modelers to create those models by using different kind of editors for the different DSLs. And we also have a common knowledge base, which is acting as a repository of common artifacts. I mean, it's pre-existing resources, which has been defined by the resource experts, another component that has been used in other deployments that can be reused in new ones. And all the interlink relationship between all those resources and components. But the knowledge base also is providing inference capabilities, I mean, reasoning capabilities in order to infer knowledge that can be provided to the user when the user is modeling those models. So not only providing resources, but also any kind of information that is required in order to fulfill those models in content assistance, as well as to be able to provide semantic validation of the models in order to ensure the consistency, the semantic consistency of the model, besides the syntactic conformance of the model to the specific languages. Of course, all those models can be stored back to the knowledge base in order to be reused in future modeling activities. So the idea is supporting different editors, is providing mostly textual editors, which are, I mean, for different models, I mean, for the ADM models. The domain-specific language is based on Tosca topologies. We are borrowing Tosca modeling entities as much as possible in order to not create a new model that needs to be learned by users, but they can rely on Tosca concepts. We are adopting a modular modeling in order to simplify the partitioning of modeling entities across concrete realms or concrete application domains. Similarly, we have another model for describing resources, which is based on Tosca type definitions. Another one for describing optimizations of containerized HPC and artificial intelligence applications. And this domain-specific language has been created in the context of the project and is not based on any existing one. We have also, as well, a model created for describing Ansible playbook for describing operational and interface operations, which has been also created in the context of the project. We are adopting different approaches for creating those models. I mean, the same model can be created by using different editors, providing different viewpoint representation, which are all in sync. So any change in one of the model editors is propagated automatically to the others. We have a main editor is textual based because it provides the highest productivity for modelers, but on the contrary, of course, require more skilled modelers, and therefore the learning curve is a little bit more pronounced. But on the contrary, it doesn't have the communication facilities that the other visual representation has. So we can provide as well an outline, tree-based, read-only representation of the same model, and a visual Canva-based graphical editor that can be in the current release can be edited by using forms editors. And in the future, it will support the creation of the models by using a palette of modeling entities that can be drag and drop in the canvas and can be arranged in order to simplify the modeling process. The visual representation offers better communication facilities, but the productivity is a little bit slower, no? Smaller. And the editors are also providing a number of significant assistant aids to the user when the user is creating those models, both in the textual and the Canva base. So the model editor is assisting the user in creating, I mean, adding elements to the model which are contextual sensitive. So at the point that the modeling you are creating the model, you are assisted by the editor suggesting you what entities you can inject, as well as content that you can retrieve from the knowledge base, which is content that is specific to the context and that fits well into the context according to the this environment, I mean, this context. So it can suggest you what kind of resources you can reuse, what kind of properties you need to rewrite, what kind of requirements needs to be satisfied for different components, and what nodes can satisfy these requirements, everything is based on the inference and reasoning capabilities of the knowledge base. Also, when you are validating the model, model deficiencies and smells that are obtained by using techniques on artificial intelligence techniques with regards to the smell database that we have collected. Another kind of suggestions, including suggestions for recommendation for the optimizations, can be inferred by the knowledge base and spotted to the user when the user is creating those models. Another feature is the semantic complexion. If the model is incomplete, in the sense that it's not satisfying a particular requirement which is required, at the point you are deploying the model, the knowledge base is in charge of completing the model and fulfilling all those missing requirements. So this is the overview of the Smart IE. For more information about the project, you can find this information here in the project portal. For more information on the IDE, and for also to download and use this IDE, you can also refer to the GitHub repository. And that's all from my side. Thank you so much for your attention, and I'm glad to answer your questions.
Great, thanks so much. Thanks so much, Jesús. Okay, the floor is open for questions, remarks. Okay, so at this, I'm sure by all means include questions in the chat for later on if you like, as we continue the workshop. Okay, fine. This concludes the formal presentation part of the workshop, and we're moving slowly towards the final session of the workshop, in which we'll also talk about what our future plans are for this workshop series. So I'd like to start off by yes.
Jen, sorry to interrupt. Before we start with the discussion, can we do the group photo for now?
Sure.
Thank you.
Okay. So there's an idea to do a group for the workshop. So that means everybody turn on your cameras. Okay, very good. Okay, so once again, the Software Forum team would like to introduce a discussion to talk about how things are going to move ahead now. And I guess a simple way to lead into it is for me to once again, by now, bore you to death with yet another presentation of another introduction to the forum platform that we have put together. So let me quickly put that up. Hold on a second. There. Okay, here we go. So once again, for the last time, let me remind you that one of the key activities of the SWForum.eu is to create an online forum, which is directed specifically at European software researchers to discuss all of the things that we've been discussing over these past 3 days in software technologies, digital infrastructures. Here you can actually see them in cybersecurity. And in order to do that, we're about to go live with a fully fledged professional platform, just like what you would see on LinkedIn or similar, with where you can participate in topical discussion groups, create a user profile, follow threads, vote, likes and dislikes and things like that. And this is for us in the European software community. And this is one of the major platforms through which we will develop the kinds of proposals that we can make to the European policymakers regarding future directions for software technologies in Europe. So this is a real chance for all of you to continue the discussion that we've been having over the last 3 days, and it certainly has been an active discussion. So please join. It should be up within the next week. You will see the register button here, and when you do register, you will see that you can register as at various levels, from individual levels to the organizational levels. Okay, so once again, I have bored you for the very last time on that in that aspect. Okay, so at this point, let me turn over the floor to my colleagues here on in SWForum.eu. I think Elizabeth, I think you had something that you would like to talk about, and so I think it's appropriate to have you take over the reins.
Yes, yes. So I just wanted to follow up on this idea of the software forum that Jonah has highlighted, because we were thinking at having, of course, this let's say digital digital tool to support interaction, but we would also like to have some, let's say, more not necessarily physical, but at least brain interaction among people that are interested in certain teams. So let me share just my screen for a second, and I hope you see this very short presentation that has to do with this idea. So this by sharing ideas and having, let's say, some brainstorming like the ones that we had in these 3 days that were very enjoyable, at least to me, and I hope also for you. We were thinking at, organizing new workshops. For instance, we are planning to have a new workshop, hopefully within 1 year, more or less with this format, hopefully in presence, but not necessarily. And also have maybe some recurring smaller workshops on specific topics, possibly having some concrete objectives in mind that could be, for instance, the development of a joint document on some specific aspect that is interesting for all of us. And of course, we will have to identify topics. Certainly, we have seen that the point about open source and trustworthiness is very interesting, given also the level of interest that has been raised by this workshop. Most likely, I see that here we have Tony. Most likely our keynotes have been the ones who attracted so much interest, but I hope also the subject per se was interesting. But probably there are others that could be interesting as well, and we would like to hear from you to try also to define an agenda for these discussion workshops that we can and we can support, of course, in the organization of these discussion workshops to allow the community to grow around these subjects. So this is one point. And on this, of course, we would welcome any suggestion from all of you. Our initial idea is to run a survey, contacting all those who have been participating into this workshop to understand whether there is a specific trend that we want to follow in this respect. So this is one point. The second point concerns the idea of creating around the fact that probably we have some common interests and common ideas, a long-lasting organization that could essentially follow up an effort that has been conducted in the previous years around what was called the Software Engineering for Services and Application Cluster. Here you have the link to the website of this cluster. I think some of you have been participating into it in the past, and the idea of the cluster was to actually have a discussion forum and also have a place where we could interact with each other. I mean, European projects could interact with each other. So the focus was essentially on European projects, and with the objective of sharing results, sharing experiences, sharing dissemination actions. For instance, we have been able to collaborate to have a stand in a very important conference that has given visibility to many results coming out of these projects. We have been able to write papers together. So for instance, here there is a link to a paper that we, sorry, I just pushed on the button, but this is the paper that we have published and that has to do with the identification of some challenges that have been then reflected in the subsequent work programs. And in general, the idea is also to act as is to influence, let's say, the research agendas, the European research agendas by coming out with new ideas and for further development of our research. So the idea is to, as I was saying, is to create something that is long-lasting and independent of the specific person who at a certain point in time is taking care of these activities. For the software engineering for services and application cluster, there was a group of people who essentially organized the activities and developed them. And I think that that group was quite successful, but of course the point is that an organization should live beyond the participation of a specific person or a specific group of people. And so we would really like to understand whether there is an interest to create something that can live beyond the specific individuals that will focus on this organization in a specific point in time. And with this respect, we have been thinking, for instance, at how other organizations are working, starting from ACM, IEEE, to other more European organizations. So we have got some ideas on what could be done in that respect. And on this also, we would like to collect your interest and see whether we can really start something together in this respect. So I think these were essentially the two things that I wanted to highlight. And of course, we will follow up on these two aspects, at least trying to collect your feedbacks and to understand how we want to move on all together. And clearly, if you have feedbacks already now, they will be more than welcome. We have some time for the discussion. Thank you, John, for giving me the opportunity to speak.
Yes, and thank you, Elisabetta, for pointing these things out. Before I turn over, first of all, if there's any reactions by any means, by all means, please speak up. I would like to take this opportunity before turning over the floor to Leire to thank all of you for coming and participating. A special thank from me to our keynotes. You were absolutely fantastic. And to my colleagues in IEEE software world, like Diomedes, who I see here participating, who has supported our call to action. Thank you again, Diomedes, for your help and your support with your colleagues. We appreciate it very much, and I hope this is a token of the interest of the European community to make this really work. So I've had my chance to have my say now, and I'd like now to turn the floor over to Leire for some final words from her part.
Thank you, John, and thank you, Elisabetta. So I would really like to thank you all for attending, most of you all 3 days. I really hope that you found the talks, both coming from the keynote speakers as well from the different research activities being carried out in Europe, interesting. And I hope you also found the discussions interesting and challenging. The recordings of all 3 days will be put up in YouTube, in our channel. Julie, correct me if I'm wrong.
Yes.
Thank you. In the upcoming weeks. So please tune in to our YouTube channel to revisit the talks during Easter, for instance. That would be more thrilling than watching a series, a chapter of your own series. So yeah, again, thank you very much and hope to see you soon. If you have any comments or any suggestions for the next editions of this workshop, and also for the more technical workshops that Elisabetta mentioned, please feel free to suggest them and we will try to accommodate them as much as possible. So thank you very much.